without wasting any more time. I'm sharing my screen to you all. Okay. Now, this is the chapter 6, and chapter 6, 6.3 part. The estimate of orthogonal road construction in plain area. For the plain area that is in Tarai, this is not the road constructed in the hilly area. For the hilly area, there is the cross slope, or the slope of the ground has some inclination along the cross-sectional direction, that is called cross slope. For the plain road, the cross slope is nil, because the if you cut the section of the road for any part of the road, then the ground level remains plain, because there is no inclination of ground level for the plain road. Okay, this type of road is generally constructed in the Tarai, and the generally road has the cross section of the trapezoidal section, and this section may be filling or is in cutting. Okay, sometimes the section may be in cutting, sometimes the section may be in filling. So that for the cutting section, we have to excavate the soil below the ground level to make the box cutting of the section of size trapezium, as in the cutting section shown in figure here. For the filling portion, the formation level is generally above the ground level, and at that time to make the road level of the road level, we have to fill the ground level up to the formation level, and making the section as the trapezium section, as shown in the filling section here. So for the filling, you must know that the formation level must be greater than the ground level. Formation level must be above the ground level. If the ground level is above the formation level, in the second figure you can see here, if the ground level is higher than the formation level of the road, B the width of the road, capital B the width of the road, this length is B is the formation width of the road. Okay, and this formation width, formation level is lower than the ground level here in case of cutting, and this cutting soil has to be dug out. Okay, and and for the filling portion, the the portion should be filled and make the shape like this, the trapezoid, and the formation level you can achieve above the ground level after filling this ground level up to the formation level. Okay, this is for filling. Formation level must be greater than ground level. For cutting, ground level must be greater than formation level, or formation level is less than ground level. Now, generally, earthwork for road construction includes the preparation of the formation level, either by cutting or by banking or filling. Filling is also called banking. Okay, the cross section of road is of trapezoidal shape. This is the shape of the road generally. That may be in cutting or in filling. Okay, this is the case of the plain area. There is no cross slope of the ground slope along the cross section direction. Plain road has no cross slope. That is the transverse slope. That is the ground level at the cross section direction is plane. This ground level is this ground level is remains plane. This black line is the ground level which is remains plane. And for the trapezoidal section, you can find the area of this section, area of this cross section by using the trapezoidal formula. That may be the area of this section may be PD plus SD square. S is the side slope. S is the side slope. The side slope for filling is taken as SF, and the side slope of cutting is taken as SC. Is to 1. This is the horizontal is to 1. This is the slope. Okay. Now you have already studied in the previous semester of the irrigation engineering. You design about the canal. Okay, the canal may be in cutting, canal may be in filling. Embankment is calculated there. For the cutting section, the area of the section is calculated as the BD plus ST square. The S is the side slope, as we have studied that in the irrigation chapter. Okay. Similar, I have considered here the cutting slope as SC and the filling slope as SR. For the trapezoidal section, cross section area is equal to A is equal to BD plus SD square. You know this. And where B is formation width of the road, D is depth of polar cut, S is the side slope. So for area of cutting, the side slope must be provided as the cutting side slope, and depth must be provided as the cutting depth below the ground level to the formation level. Okay. Instead of depth, the formula is same. Area is equal to BD plus SD square. For cutting case, A is the area of cutting, and B is the width of the road, and D is the depth of cutting. So I have putting the value of D as DC. Okay, for cutting case, and the S is the side slope for the cutting, and this SC, and D is the depth of cutting DC square. The formula becomes area is equal to B DC plus SC DC square for the cutting portion. And similarly for the filling portion, the area is also same. Area is equal to BD plus ST square. This formula is same, common formula. But instead of depth of cutting, you should use the depth of filling, and instead of the depth slope of the cutting, you must use the slope of filling for the filling purpose. So portion, okay. So area of filling will be BDF plus SF DF square. This is the common formula is here. Area is equal to BD plus SD square, and this formula can be changed to the cutting or filling by converting the cutting depth and the cutting slope in the common formula. Okay, we can use in this way. You can provide the cutting slope as S1 and cutting filling slope as S2 also in the similar manner BDC plus S1 DC square, or area fill is equal to BDF plus S2 DF square. Okay, you can do in this way. I have kept here the formula, same formula. Now, the quantity of earth ore can be calculated. The quantity of earth ore can be calculated by multiplying the cross-sectional area with the length of the section. That is, the length of the sections means the length between the sections. Okay, this is length between the sections. Length between the sections. Length between the section. Okay, length between the sections. Cross-sectional area into length between the sections, you will get the volume of the earth. That is, area is in meter square and length is in meter. After multiplying this, you can get the quantity of earth. That is, quantity of earth is volume of earth is in cubic meter. There you know that earth is measured in the cubic meter. So first of all, determine the cross-sectional area, and that cross-sectional area is multiplied by the length between the sections, and you will get the quantity of earth. This is the simple thing. Now, how can there are various methods to find the quantity of earth for the plain road? The various methods can be used. This is the theoretical part. I am just talking about it, and after doing the theoretical part, we start the numerical problem today. Okay, for the plain road. Now, mid-section area method. This is the mid-section area method. Is generally, I look at this section. This is the plan of the road. This is the plan of the road. I have taken the two sections, section 1 and section 2. The length between this section is L meter. Okay, with the formation width of the road is B meter. This is the plan, and depth of cutting or depth of filling for the section 1 may be D1, and section 2 the depth may be D2. So that for using the mid-sectional area method, you have to find the average depth of this section first. Average depth of this section, DM is calculated. The average depth of this section will be D1 plus D2 divided by 2. Okay. First of all, you have to calculate the average depth between the section. The section 1 depth is D1, section 2 depth is D2. Then you have to find the average depth of the section first, mean depth of the section, as the average value of D1 and D2. Now, with the help of this average value, you calculate a DM, find the mid-sectional area using the same formula AD plus BD plus SD square. The same formula is used to find the sectional area. That sectional area is mean sectional area if you use the mean depth. Okay. Now mid sectional area will be area mid is equal to use the same formula BD plus SD square. Same formula is used BDM plus SDM square. BDM plus SDM square. This formula is used to find the mid sectional area. This mid sectional area may be cutting area or maybe filling area. If the depth of D1 is cutting and depth of D2 is cutting, then the mean area will be cutting mean depth will be cutting mean depth, and the area mid will be the cutting mid cutting the area. Okay, and at that time you have to put the breadth into depth of cutting plus slope of the cutting, side slope of the cutting, and the mean cutting depth. Okay, you can get the area mid of cutting. Similarly, if the depth for the section 1 is filling, D1 has filling depth and section 2 has D2 has the filling depth, also the filling depth. At that time, you can take the mean depth as D1 plus D2 divided by 2. Okay, and find the mid area using the um, trapezoidal formula to find the filling sectional area as mid area. BDM plus SF into DM square, okay, for the filling area. But you cannot average the depth. You cannot make average of the depth if the first section is in filling and the second section is in cutting. You cannot take the average depth between the cutting section and the filling section because they both of them are different type of sections. So you cannot take average in between them. For the portion of the road, if the road uh, is uh, is from the changing section from cutting to filling. If there is the for the section 1, if the depth of D1 is equal to cutting depth, and the for the section 2, if the depth is of filling depth, at that time you cannot take the mean area, mean depth. Okay, average depth cannot be taken because the cutting and filling are different depth, they cannot be taken as the average depth. So in between from the cutting to filling or filling to cutting, there is the depth of zero depth. While passing the road from cutting to filling, there must be the zero depth. So that zero depth is it is not the part of the cutting depth, or it may not be the part of the filling depth. So it can be taken as the average between the D1 to zero depth and the 0 to D2 depth can be average. So that if D1 is filling and the zero depth is there in between it, and then the from D1 to zero depth, that must be that section is in filling. Okay, from zero depth to cutting depth D2, and that the section must be in cutting. So that the average is taken for D1 and 0, and 0 to D2 in the similar way to find the mean depth of the section. Okay, now volume of earthwork is calculated by using can be calculated by using the formula. Okay, this formula can be used. Similar formula can be used. This formula can be used. Okay, this formula can be used. Volume of earthwork as quantity of earthwork. That is after finding a area mid sectional area, that area is multiplied by the length between the section. You can get the volume of the earthwork, whether it is in cutting or it is in filling. Accordingly, you can find the sectional area. This is the important method. In the examination, if it is not asked to work out the earthwork for the plain road, not mentioning the specific method, then you can do using the mid-section area method. This method is relatively faster than other methods. Average depth method can be used. Average depth method is also called mid-section area method. Okay. Hello.
As you sir.
Hello. I will understand what I am telling. Hello.
Yes, sir. We understood, sir.
This is I have considering this as the mid-section area. This is the theoretical part. Sometimes you may be asked in the question as a theory also. Okay. What are the different methods of taking out quantities of the earth ore? At that time, you have to explain about the mid-section area method, mean sectional area method, and the pismoidal formula method. Okay. Now, for the second method, this is the mean section area method. As in the first method, we use the average depth first, and with the help of the average depth, finding the sectional area. That sectional area is mid sectional area, and that area is multiplied by the length between these sections to get the volume of the earth. Okay, in the first method. In the later method, in this case, we have to find the sectional area of both the sections. We have to find the area of the section first, and we have to find the section area of the section second. And after finding the area of the section 1 as A1, and after finding the area of the section 2 as A2, and you have to find the mean section area by taking the average sectional area in between these, and the mean section is calculated, area is calculated, and that area is multiplied by length between the section to get the quantity of R. For the section 1, the area of section 1 A1 will be A1 plus BD. A1 is equal to BD1 plus SD1 square. Area of the section 1 will be BD1 plus SD1 square. Area of the section 2 will be BD2 plus SD2 square. Okay, and find the mean area. AM is equal to A1 plus A2 divided by 2. Okay, and that mean area is multiplied by length between section. You get the volume of the earth. These methods, in this method, section area of two consecutive sections are worked out, and the average area or mean area is calculated. This mean section area is multiplied by length between two sections for calculating earth quantity. That is, from the previous figure, area of the section 1, 1, 1 will be A1 is equal to BD1 plus SD1 square. Okay, and for the section 2, the A2 will be BT2 plus SD2 square. After finding the A1 and A2, take the mean section area as area mean is equal to A1 plus A2 divided by 2. Average section area is calculated. And the quantity of earth will be, volume of earth will be area mean into length within the section. Okay, do you understand this? Hello? This is the second method. In the first method, we take the average depth first, okay, and with the help of average depth we find the sectional area. That sectional area is mid sectional area, and that is multiplied by length between the sections. Will get the volume of earth in the first method. In the second method, we have to find the respected sectional area first. We have to Hello,
हजुर
hello.
सर हजुर सर हजुर
Line is disturbing us here. Uh, Now let me move to the session. We have already discussing. Let me start. Now this is the mean sectional area method. This method is generally taken for by considering the average area of the in between two consecutive sections. The average area is taken, and that is multiplied by the length between the section to find the ortho.
Sir,
Okay,
slide share হয় না।
slide is not here. I am sharing this slide to you here. Now is it sharing? Hello.
yes sir yes sir
বয়স apa?
Okay. Now let us move to the third method. Okay. This is the second method. And third method is using the Prismoidal formula. As you know, the Prismoidal formula, this method is combination of the both mid-section and the mean section area method. This is the combination of both mid-section and the mean section area method. For this method, the formula is used as the Q is equal to A1 plus 4 area mid into A2 divided by 6 into length. Okay, which becomes the value will be L by 6 A1 plus 4 area mid plus A2. This A1 and A2 are taken from the each section area, and the area mid is taken by considering the average depth of the between the section, and the section area is taken as area mid. Okay, and two section areas A1 and A2 from the mean area, and the 4 area mid is calculated using the mid sectional area, and altogether you have 6 areas here, 4 area mid, 1 area 1 and 1 area 2, that is it becomes 6, and getting the average of these 6 areas, you have to divide by 6. Okay, and that will be the area, and it is multiplied by length between the sections, and you can get the formula as L by 6 A1 plus 4 area mid plus A2. Okay, this is the Prismoidal formula. This Prismoidal formula can be used for calculating Prismoidal formula. This is called Prismoidal formula, and this Prismoid formula is Prismoidal formula calculating the quantity of orthon by using this formula. And this method is to calculate the using the Prismoidal formula. This method is very long in comparison to the average depth method or mid sectional area method and the mean sectional area method. You have to find the each and every sectional area. You also calculate the mid sectional area, and with the help of a mid sectional area and each sectional area, you can find determine only by multiplying L by 6 to find the Prismoidal formula. Okay, this formula is used. Note the consecutive sections must be either both in cutting or both in filling. That is, the average depth or sectional area should be taken for both sections in filling or cutting. I have already discussed it, and now for the now I'm going to elaborate the numerical examination problems related to these all three methods. Okay, and this is the ABCD, that is starting of calculating the sectional area using the three methods. This is we are talking about the we are in nursery class, so we are starting the ABCD. Okay, such type of questions cannot be asked in the examination, but this is for the use of three different formulas. How can we calculate the volume of the earth? Okay, the question number 1, calculate the quantity of earth for the road portion of 100 meter having formation width of 10 meter, and the side slopes of cutting and filling are 1:1 and 2:1 respectively. The first section and the second section has a cutting depth of 0.90 meter and 1.20 meter respectively. Use all the three methods. You are asked to find the volume of earth or quantity of earth using the three methods. According to this question, I have drawn the plan. Yeah, the first section and the second section. For the first section, depth of cutting is given as D1 as 0.90 meter, and for the second section, the depth of cutting is given as 1.20 meter. So you can take the average in between the first section and the second section, because both of these sections have the cutting depth of 0.90 and 1.20. Both of them are the cutting. So for cutting, you can take the average depth. Okay, using the mid sectional area, first take the average depth. Average depth of part dm is equal to 0.90 plus 1.20 divided by 2. Okay, d1 plus d2 divided by 2, and the value will be 1.05. Using this average depth, find the area mid BDM plus SDM square. The S must be the cutting depth, so side slope must be taken for the cutting. Okay, SC must be cutting. The side slope for cutting is given as 1:1. The SC value is 1. So B is formation width is given as 10 meter here. So the B is 10 meter. 10 into 1.05 is the average depth, and BD plus SD, sorry, S is 1 and 1.05 square. You get the mid section area of 11.6025 square meter. Okay. Now the volume of earth using the mid section area, that volume Q is equal to area mid into length between the section. Area mid is 11.6025 into length between the section is 100 meter given here in the question. Okay. Now the volume of earth will be 1160.25 cubic meter using the mid section area method. Now for the second method, mean section area method, we have to find the respected section area first. We have to find the respected section area using the depth of each sections. Okay. Now the area 1 will be for the section 1. Area 1 will be BD1 plus SD1 square. Okay. And BD1 plus SD1 square. B is 10. D1 is 0.90. S is cutting depth, so the cutting slope is 1 into 0.90 square. You get the value of 9.81 square meter for the first section. Similarly, for the second section, the area 2 will be BD2 plus SD2 square. Okay, and use this formula, you can get the volume of area 2 as 13.44. After finding the each section's area, find the mean area. The mean section area will be area mean, which gives the value of 0.981 plus 13.33 divided by 2. This is the mean area, and this is the mean area of the section. This mean area is 11.625 square meter. Okay, this you can find mid area. Now volume of earth using the mean section area will be area mean into length between the sections. You can find 11.625 into 100, which gives the value of 1162.50 cubic meter. You can see from the first method and the second method, the volume of earth is relatively nearer value is here. Exactly the value is not same, but they remains nearly equal. So you can use mid section area method or mean section area method. For the earth calculation, small variation of in volume does not matter. That's why if you use mid section area method, you will get this amount of earth. If you use mean section area method, you can get this amount of quantity of earth. Okay, using both methods. Now using third method, that the Pismoidal formula method, the volume of earth is calculated by Q is equal to L by 6, A1 plus 4 area mid plus A2. Now A1 is calculated as 9.81. A2 is already calculated as 13.44 here, and area mid also calculated as 11.6025 in the previous methods. Okay, so taking area mid as 11.6025, A1 as 9.81, and A2 as 13.44, and L as 100 meter. Using this, the volume of earth will be L by 6 A1 plus 5 area mid plus A2, put the values, you will get the value of 1161.00 cubic meter. Tentatively 1160.25, 1161.00, and 1162.50. They are, all these values are very near. After for examination of more than 1100 cubic meter of volume, and there is a variation of 2.25 cubic meter here. Okay, the minimum value and the maximum value will be a difference of 2.25 cubic meter for after examination of the 1100 cubic meter of the 1162 1160 cubic meter of the ortho. So in this way you can calculate the ortho. This is the ABCD for the calculation of quantity of ortho. Okay. Hello. Hello.
Yes, sir.
Do you all understand this? Okay. I think uh, I have
Yes, sir.
just showing you how the quantity can be calculated using these methods, using different techniques, using the mean section area method, using the mid section area method, as well as the pyramidal formula method. Okay, and this is the three methods. If you are asked in the question with the for finding the quantity of each item using the specific method, then you have to do in this way. Okay, for you can utilize formula using in this way. So this is the simple sample. Okay, now let us move to the second question. This is the question, and we calculate all the volume of earthwork and the quantity of earthwork for the given portion of the road, and the different areas are given here. RL of the ground also given here. This RL of ground is taken from the survey. Okay, and we have to find the quantity of earthwork for the road portion, and the road width is fixed, and cutting and banking slopes are also fixed according to the type of the soil, and there may be the rising or falling of the longitudinal section. That may be road may be in falling gradient, rising gradient, or maybe in plain surface. Okay, according to that we have to find the quantity of the respected sections. And now this is the question. This may be asked in the final. Okay, this type of question may be asked in the final. Now we are doing ortho calculation for the plain road. Okay. Now calculate the quantity of ortho required for the portion of the road having width of 7.5 meter. And the B formation width of the road is 7.5 meter. With side slopes in cutting and banking as 1:1 and 2:1, horizontal is to vertical respectively. Side slope in cutting is 1:1 and that for filling is 2:1. The road possesses rising gradient in of 1 in 100 from Chennai 0 to 200 meter. From Chennai 0 to 200 meter, the good road is in rising gradient. That is the formation level of the Chennai 200 meter is higher than the Chennai 0 meter. That is the rising gradient, and takes level surface from 200 to 300 meter. That is the road is plain. That is the RL of the formation level from Chennai 200 meter to 300 meter is same. There is no change in elevation between the formation level between the 200 to 300 meter here. And again attains falling gradient of 1 in 90 from Chennai 300 to 600 meter. Again there is the sloping downward gradient, that is the falling gradient from Chennai 200 to 300 to 600 meter. That is the RL of the formation level of the 300 meter is greater than that of 600 meter. And the road is road formation level is being decreasing with a constant rate of 1 in 90. Okay, and the formation level at Sen is 300 meter is given as 501.30 meter. You are provided with the level of the road surface, that is the formation level of the road surface as 501.30 meter as for the chain is 300 meter. The survey data referred to this section is given below. The survey data referred to this section is given below. There is a channel. The channel is provided along the interval of 100 meter. Okay, 0 meter, 100 meter, 200 meter, 300, 400, 500, 600. The length between these sections are 100 meter. Okay, you may be provided with different channel intervals also. I look at the question properly, but at this time the change is at a constant interval of 100 meter. Now RL of ground is given as the ground level is 500 meter, 500.15 meter, 499.25 meter, 499.75 meter, 499 meter, 502 meter and 501.40 meter respectively from channel and 0 meter to 600 meter provided in the question. Okay, this is the question. This is we have to first calculate the depth of cut, height of bank, etc. It is not given here in this question. We have to calculate. Okay, and we must know where is the channel of that is cutting channel or whether it is the filling channel or whether it is the change in channel or where is the position of the zero depth channel. We have to calculate from this data provided. Okay, in the previous numerical number 1, you are given all the data required for the calculation of the earth work as the depth of cut is given, and you don't have to calculate other data because the direct depth is given here, and the side slope and the formation would be also given, and the change and the portion and the length between the consecutive sections also directly given here. That's why this can be done directly here. Okay, but in this question directly these data are not given. You are given only the side slope and the formation weight. Other values have to be calculated by yourself from the given data. Okay, now for the calculation of the data we have to calculate the RL of the RL of the formation level for the various channels and comparing the formation level with the ground level to know the whether their section is in cutting or is in filling. Okay, without I have already taught you in the first figure of this estimation of road work in construction plain area. You can look at this figure. The formation level, if formation level is higher than the ground level, other section is cutting, filling. Okay. If the formation level is lower than the ground level, then the section will be cutting. That is, ground level is greater than formation level, then at that time that section is in cutting. If the formation level and the ground level are at the same level, if the formation level and the ground level are at the same level, then there is no need of cutting and filling. There is no need of cutting and filling. Okay, you must understand this. For your remember, you can remember in this way. If the formation level is greater than ground level, that is filling. If the formation level is less than ground level, that is cutting. Okay. Now, we don't know whether the sections are in cutting or filling. First of all, we have to find the sections. Okay. Now, this is the challenge. This is the question given here. Now, I am going to solve this problem. First of all, we have to find the depth of cut or the height of bank. Okay. Now, for the change, you can look here. The change is given. The change is same here. I have keeping the change here as in the question, and the RL of ground also same here as in the question. Now, for the 300 meter channel, the RL of formation level is given as 501.30 meter. Okay, this 501.30 meter is provided at the formation level, which is provided at channel 300 meter as 501.30. All these black letters are provided in the question. Okay, black colored letters are taken from the question because 300 meters formation level is given as 501.30 meter. Now from the question, from channel 00 to 200 meter, from channel 00 to 200 meter, rising gradient of 1 in 100. If you travel the 100 meter from 00 to 100 meter, there is the rise of formation level from of 1 meter. Okay, there is the rise of 1 meter because the rising gradient is given as 1 in 100. 1 in 100 into distance between from 00 to 100 meter change is 100. So 1 meter must be rise. That is the formation level of the 0 meter challenge must, and the difference between the formation level of the 0 meter challenge and the 100 meter challenge must be 1 meter. That is, the 100 meter challenge must have the 1 meter formation level higher than the 0 meter challenge because it is rising gradient. Starting from 0 to 100, it is a rising gradient. If it was a falling gradient, then at that time the 1 meter will be fall. That is from 0 meter to 100 meter, the road will be in the falling gradient means the RL of the formation level of the 100 meter channel will be 1 meter below the RL of the channel of the RL of formation of the 0 meter channel. Okay, in this way you have to understand. From 00 to 200 meter there is the rising gradient. That is the distance interval between the two consecutive sections is 100 meter. That's why 1 in 100 is the gradient value, and that is multiplied by 100 you will get the 1 meter value. Okay. Hello. Hello.
So 200 and 300 channels have the same formation level wise, huh?
No. From 0 to 200 meter is same. That means if the section is from 0 to 200, the distance is 200 meter. Oh, 0 बाट 200 मिटरसम्म त 200 मिटर भयो नि चाहिने त है 200 मिटरमा कति बढ्ने भयो त 2 मिटरले बढ्ने भयो नि यहाँ त एक एक सयलाई हेर्न पर्यो पहिला 0 to 100 1 मिटरले बढ्यो 100 देखि 200 पनि 1 मिटरले बढ्छ के 0 to 200 जाँदा 2 मिटरले बढ्नु पर्यो नि त हैन त बुझ्नु
यसो
प्रत्येक 100 मिटरमा त 1 मिटरले बढ्नु पर्यो नि त 0 देखि 200 मा जाँदाखेरि हो कि हैन अनि के भनेको छ त भन्दाखेरि चेनेज 200 देखि 300 सम्म त लेभल सर्फेस भनेको छ ओके लेभल सर्फेस भनेको हुनाले 300 मिटरमा जति फर्मेसन लेभल छ 200 मिटरमा पनि त्यही फर्मेसन लेभल हुनु पर्यो किनभने सम्म छ भनेको छ नि त नो राइजिङ ग्रेडियन्ट नो फलिङ ग्रेडियन्ट त्यो त सम्म छ भनेपछि त 300 मिटरको चाहिँ फर्मेसन लेभल 501.30 मिटर हो भन्दा 200 को पनि के हुनु पर्यो यही फर्मेसन लेभल हुनु पर्यो नि त बुझेनौ है यो फ्रम चेन्नई 300 600 फलिङ ग्रेडियन्ट 1 in 98
ओके सर बुझे
1 in 90 मा डिस्टेन्स कति छ यो पनि 100 मिटरको छ प्रत्येक 100 मिटरमा कतिले झर्नु पर्छ त 1.11 मिटरले डाउन हुनु पर्छ है त्यो भएको हुनाले अब हामीलाई दिएको छ formation level कहाँको त भन्दा we have given the formation level of 300 meter we have to start from the 300 meter okay we have to start from the 300 meter but from 300 to 600 meter there is falling gradient of 1 in 90 so for each 100 meter interval the falling of formation level must be 1.11 meter so from 501.30 meter deduct the value of 1.11 meter towards the 400 meter okay now for 501.30 minus 1.11 it will gives the value of 500.19 meter okay after getting 500.19 meter again deduct 1.11 because the gradient is same you will get the 498.08 meter again deduct 1.11 meter you will get the value of 497.97 meter okay
त्यति आउनु सर 498
hello
498.08 आउनु के त्यहाँ
97.97
499.08 आउँछ
hello from 498.08 deduct 1.11
त्यहाँ 498 आउनु भनेको के 499.08 आउँछ
99 okay then this is mistake okay thank you for your comment okay 498.97 okay 500.19 minus 1.11 what will the value this is okay You cannot. 500.19 minus 1.11, the value will be what? 499.08. Okay. And this is okay. Now, from the left hand side, go from the left hand side of 300 meter. From 200 to 300 meter is the level surface. That's why the formation level of 300 and 200 must be same. That's why 501.30 meter. Now, this data 499.30 and 500.30 is not provided in the question. Only the rising identity given here. So, according to the question, from 00 channel to 200 meter channel, the RL of the formation level must be rise. Okay. If you calculate in the backward direction, that the level of the formation level of the 100 meter must be lower than the formation level of the 200 meter by 1 meter. Okay. If you move from 100 to 200, then rise of 1 meter. Okay. If you go calculation from 200 to 100 meter, there must be fall of 1 meter. Okay. That's why I am calculating from 200 to 100 meter, 0 meter in the backward direction. So the formation level of the 100 meter channel will be 501.30 minus 1 meter. Okay, because the gradient is same from 0 to 200 meter, rising gradient of 1 in 100. That's why for each and every 100 meter there must be rise of 1 meter. If you do calculation from 00 to 200 meter, if you calculate in the backward direction, then you have there is the fall of 1 meter from 200 to 100 meter and 100 to 0 meter also 1 meter fall. Okay, that's why after knowing the formation level of the 200 meter, deduct the 1 meter from this value, you get the value of 500.30 meter. And from 500.30 meter, again deduct 1 meter, you get the value of 499.30 meter. In this way, you can calculate the formation levels of the.
97 आउँछ.
Hello?
98 हैन. 497 आउँछ के सर यताको.
कताको?
त्यो 98 वाला चाहिँ 97 हो के.
त्यो रेड वाला सर, रेड के रो को लास्ट.
1.97 आउँछ.
हजुर.
Okay. This is the formation level that I have calculated. Okay. You can understand in this way. Now, compare the RL of ground and the RL of formation level. Compare the RL of ground and the RL of formation level. Now, in the first 00 channel, the RL of ground is higher than the RL of the formation. If the formation level is lower than the RL of ground level, then that is cutting. Isn't it? Hello. Ground level is above the formation level. We have to make the road level to the formation level. At that time, we have to dug out the excavate the soil of that area. Okay. So ground level is higher than the formation level. There is cutting. So deduct 499.30 from 500. You will get the value of 0.70 in cutting. Okay. There is no height of fill for this 0 meter channel. Now for 100 meter channel, the RL of ground is lower than the RL of formation level, because formation level is higher than the ground level, so there must be filling. 500.30 minus 499.75, you will get the value of 0.55 meter. Okay. Now for 200 meter channel, formation level is higher than ground level, that is also filling. Deduct 499.25 from 501.30, you will get the value of 1.05 meter. Okay. Now for 300 meter, the RL of formation is 501.30 and the RL of the ground is 499.75. At that time, the formation level is also greater than the ground level. It is also filling. So deduct this value, you will get the value of 1.55. Now for 400 meter channel, the formation level is 500.19 and the RL of ground is 499, which is less than the formation level. That is means there is filling of 1.19 meter. Okay. Now for this, the ground level is higher than the formation level. For the 500 meter channel, you can see here the ground level is higher than the formation level, and this is the cutting. Okay, this is cutting. The value of this will be 0.08. This is 92, and this will be 1 and
2.92, sir.
2.92. Okay, 2.92. This is the depth of cut because ground level is higher than the formation level. Now compare, move towards the 600 meter channels. Again the ground level is higher than the formation level. Okay, at that time the cutting depth will be subtract 497.97 from 501.40. For this is 3, and from 13 to 03, 33, and this is
3.439.
3 point. Okay. Okay. Hello.
Yes, sir.
I will understand, I think, how I am calculating the formation level of the different changes. The formation level is not given at the 0 meter change here. So it is given at the midway of midway of any change. Change can be given at the formation level. You may be provided formation level at the end of the change. You may be provided at any place of these changes, or starting of the changes. If you provide start from the starting, the calculation may be easier. But if you provide, if the formation level is provided at the intermediate point, then you have to go forward and backward to calculate the formation level of other changes in this way, according to the gradient provided. Okay. Now the calculation is done in this way. If you don't understand, and then you will understand in the next numerical problem also. We have to calculate in this way in the next numerical problem also. But according to the provided gradient, we have calculated these formation levels. Okay, and after finding the formation level, compare the ground level and the formation level. If the formation level is greater than ground level, there will be fill. If the formation level is less than the ground level, there will be cut, and accordingly the depth of fill and cut is calculated. Now look at the scenario of the depth of cut and fill. Now for the first change, that is 0 meter change, there is depth of cut. Okay. For the second change, 100 meter, there is height of fill. You cannot take average value in between 0.70 and 0.55 because the road is passing from cutting to filling. The road is passing from cutting to filling in between 0 meter channel and the 100 meter channel. So you cannot take average value of 0.70 meter and 0.55 meter because the cutting and filling filling depth are just opposite depth. They cannot be averaged. So in between 0 meter channel and the 100 meter channel, there must be the zero depth, because while passing the road from the cutting to filling, there must be zero depth. And from 100 to 400 meter channel, all the channel has the filling depth. You can take average in between 100 to 200, 200 to 300, and 300 to 400. You can take average because all of them are the filling depth. You can take average between the filling depth. Okay. Now from 400 to 500 meter channel, again this depth is 1.19 depth is filling depth, but for 500 meter channel the 2.92 depth is cutting depth. You cannot take the average depth in between the cutting, filling and the cutting. So while the road passing from filling to cutting, there must be a zero depth in between these channels, 400 and 500 meter. Okay, that channel have to be calculated. That channel has to be worked out for determining the zero depth channel. Now for channel from channel 500 to 600, This is also the cutting depth, and the 600 channel is also the cutting depth. You can take the average depth in between it. Okay, in between them you can take the average depth. Look at the scenario of the changing of the depth. If the depth is changed from cutting to filling, there must be zero depth in between it. Then okay, if continuously and filling or continuously cutting, and there is no need of finding the zero depth channel. For the last portion of changing the filling to cutting, there is also in between 400 and 500 meters there must be zero depth, that must be none. Okay, for calculating the quantity. Now let us start move.
Sir,
Hello,
with the height of field 2.05 आउँछ
where
त्यो थर्ड कलममा
third 2.05 501.40 minus 497.97. How 10 minus 73? Okay, 13 minus.
Yeah,
So third go sir 499.25 minus 501.20.
Third go
05 लेख्न हो नि त 2.05 भन्छ के
10 बाट 5 by 5 बाँकी हातलाई एक आयो 3 बाट 3 बाट 0 भयो हैन 11 9 सरी thank you okay. Now this is the 2.05. okay. Now with this data and the ground level formation level, plot the data of the longitudinal section of the road. Okay, first of all you provide the longitudinal section of the road with the help of ground level and the formation level. Okay, now I have provided this. Look at the RLs here for the ground level and the formation level. Look at the RLs of ground level and the formation level. Okay, the maximum RL is 502, I think. Okay, maximum RL is 502. The minimum RL is 497. Okay, 497. You can scale accordingly. The minimum RL is 497.97. Okay, 497.97 minimum RL. So I have started from the minimum RL as 496, starting from the lesser value than the 497, 98, 99, 100, 1, 2, 3. Okay, maximum value is 502. So I go up to 503 here in the ordinate direction, providing the RL. Oh. And in the Africa direction, I have taken the channel. 0 meter channel, 100 meter, 200, 300, 400, 500, and 600. These are channels. Now plot the data. RL of ground, RL of 500, 497%, 499.25, 499.75, 499.20, 502, 501.40, etc. And you can plot the data of these points of the blue color. I mark these points from the ground level. Okay. Now put the formation level also 499.30. This is 499.30. Okay, and 500.30. This another data is 500.30. This one is second plot. Third is 501.30. 501.30 is third, and this is also the 501.30. Okay, and another one is 500.19. This one is 500.19. Okay, and 599.08 for the 500 meter channel. 599.08. You have to move here. 99.08. This is 99.08. Okay, this is slightly greater than 499. Okay, 499 is this. It is slightly greater than this. Okay, this value is here. Now this value must be here because the mist must be. If you plot the line of same gradient, having same gradient, then this must be here. Okay, and these data must be at the same line. Plotting. This is the same line. Okay, this is the plot, and it's difficult to make these things. Laptop or computer is very difficult. Now the yellow line or orange line is the formation level, whereas the blue line is the ground level. These can be joined by using the your freehand joining can be done in the examination, but I am doing the straight line joining here because it is difficult for me to use in this way. Okay, plot the data, of formation level and the ground level. You can get the such type of curve by joining. This is the longitudinal section. Okay, now if the ground formation level is above the ground level, at the up to from d is equal to 0 to d is equal to 0 for the second d is equal to 0 here, because the depth of here is the depth of fill. Here is the depth of fill. Okay, here is also depth of fill, but it is depth of cut here because ground level is above the formation level for the 0 meter channel. So we have to cut, and for the second channel of 100 meter, the formation level is higher than the ground level. Here we have the fill. So from cutting to filling, there is chance of intersection of the ground level and the formation level in between cutting and filling depth. So for this point d is equal to, for this point where the intersection of the formation line and the ground line, at this point the depth of depth will be 0. Okay, similarly for here also the formation line and the ground line is intersect here. For this section, for this also the d is equal to 0, because the section is in filling here. Before d is equal to 0, the section is here filling, and after d is equal to 0, the section is in cutting. So from filling to cutting, the road changes, and at that time in between the filling and cutting there is depth of 0 depth. Okay, this has been this can be seen from the plotting of the figure also, and you can imagine that from cutting to filling there must be 0 depth channel. Okay, again from filling to cutting there must be 0 depth channel in between them. Okay, it is the most important thing to know whether the section is in cutting or filling, or section remains uncut. Okay, or unfilled. Now for this we have to find the for all the depths there is the chainage. 100 meter chainage, 200 meter chainage, 300, 400, 500, 600, etc. For you have the for the cutting depth of 0.70 meter, the chainage is 0. The cutting depth of 100 meter chainage, cutting depth of 0.1, filling depth of 0.55 chainage is 100 meter. Filling depth of 1.19 chainage is 400 meter. Filling depth of 1.55 chainage is 300 meter. Cutting depth of 3.43 chainage is 600 meter. But for this d is equal to 0, and for this another d is equal to 0, we have to find the chainage. We have to find the respective chainage. So to find the chainage, first of all draw the straight line. And the in front of the this 0 chainage there is the chord, and after the behind the zero channel there is the fill. Okay, so the provide the straight line and draw the vertical line downwards as cutting depth of 0.7, and again draw the another vertical line from the end of this straight line and draw the depth of 0.55 meter here. Okay, and join these 2 points by the straight line. You will get the double triangle here, and with the using the proportion of this triangle, you can find the value of x. That is, this the starting channel is 0 meter channel and the ending channel is 100 meter channel. The total length of this channel will be 100 minus 0. This length will be 100. Okay, from here to here, this is 100 meter. Okay. Hundred minus 0, 100 meter. I think I have to change the color. It may be helpful for you to understand. Okay. First of all, draw this green line. Okay. Any length, you can take any length of green line. First of all, draw the green line, horizontal line, and mention the channel of 0 meter for the starting point, and mention the channel 100 meter for the ending point. And from the 0 meter channel, there is the depth of chord here, 0.70 meter for the 0 meter channel. There is the chord of 0.70 meter. For the 100 meter channel, there is the fill of 0.55 meter. So for the cutting portion, go downward vertically from the starting point, because it is cutting. So go downward vertically. Okay, downward vertically and draw a line and mention the value of 0.70 here. From the end of this line, this 0.55 meter is the filling data. So move upward, that is, draw upward of the vertical line. Okay, and mention the depth of filling as 0.55 here. Now join the ends of these two vertical lines by the by this blue line. You will get the two triangles. Okay, now from 0, 0 to the intersection point of this channel line and the end of joining the vertical lines, end of joining the exposed vertical lines, you get the intersection point over here. This point is the D is equal to 0 channel point. What will be the value of this channel? You have to calculate by using the both of these triangles and using their relation as the P by B is equal to P by B for the second channel, because they are symmetrical triangles. Both of them are symmetrical triangles. Using the symmetrical triangles formula, 0.70 divided by x for this channel, make this from 0, 0 to this intersection point of this blue line and the green line, and this point is mark the distance as x, and the total distance is 100, because the 100 meter channel is here, 0 meter channel is here. If you deduct 100 0 from 100, total length of this line will be 100 meter. Okay, you should not have to measure the line as 100 meter, only put the value only. Okay, now the remaining this part beyond this D is equal to 0, 0 point, this must be 100 minus x. Okay, this must be 100 minus x. Now use the relation of the symmetrical triangles. Then 0.70 divided by x must be equal to 0.55 divided by 100 minus x. Okay, 0.55 vertical by base, both of triangles vertical by base. Okay, vertical by base is equal to vertical by base. You will get the value of 0.70 by x is equal to 0.55 by 100 minus x. If you solve this, you can find the x is equal to 100 into 0.70 divided by 0.55 plus 0.70. you will get the value of 56 meter. From 0, 0 channels to D is equal to 0 channel, this distance is 56 meter. X is 56 meter. So the channel of D is equal to 0 will be 0 plus 56, you will get the 56 meter channel. Okay? Hello? Hello?
हजुर सर
Do you understand this?
हजुर सर बुझिरहेको छु सर
Okay. 56 meter channel is here. Is calculated. Okay. Now, from 0 to D is equal to 0 channel, the channel of D is equal to 0 is equal to 56 meter for the first case. Now, for the second case, look at the figure. For the second case, we have also the second D is equal to 0, 0 point here. Or it is calculated in between 400 to 500 meter. Draw the horizontal line, mark the channel as 400 meter for the starting point and the 500 meter for the ending point. For the 400 meter channel, there is fill. Draw the vertical line above the line and draw the vertical line below the line for the 500 meter channel. Join the ends of these vertical lines. You will get the shape of these lines as this way. Okay. This is the horizontal line. This is the green line. Okay. First of all, draw the horizontal line. Mark the channels. Starting channel as 400 meter and the ending channel as 500 meter. For the 400 meter channel, there is fill. So draw vertical line above this line as 1.19 meter vertical. Okay. And from this 500 meter channel, this is the cutting depth. That's why I draw the vertical line below this line. Okay. Now join this. Join these lines. Okay. Join this line. And then at this point, intersection point is the D barabar 0 channels, and provide this length as x meter from 400 to D barabar 0 channel. This is the x meter, and the remaining part of this from D0 to 500 meter is 100 minus x, because the total length is 500 minus 400 up to here is 100 meter. Okay, this remaining part will be 100 minus x, and use the same relation x by this is 1.19 by x is equal to 3.92 by 100 minus x. You will get the relation x is equal to 1.19 into 100 divided by 1.19 plus 3.92. You get the value of 23.29 meter. Up to from 400 to this channel is 23.29 meter. The channel of the D barabar 0 will be 400 plus 23.92 meter, which gives the value of 423.29 meter. Okay, in this way I did, but for our case the value is changed. For our case 2.92 is here and 1.19 is here. 2.92 is here, 1.19 is here. This is 2.92. The value will be changed. Okay, will be changed. 2.92. There was a mistake during the calculation. What will be the value? Calculate. 119 divided by 119 divided by 1.19 plus 2.92 2.92. Okay. 28.95 should be after adding this 28.95 meter, then is of 428.95. meter. Hello? Do you all understand this? Hello?
Yes, sir.
Now our Our time is over. That's why I have done up to this only. Okay, for today we'll do from this after we have calculated all these things here. For the first challenge is 56 meter, and for the D is equal to 428.95 meter here. 428.95 meter over here. 28 point meter is here. Change. This will be 28.9. This data will be changed. This data will be changed. Will do. This was for today. Let me take your attendance first. I have downloaded the attendance list. 28 students are here.
सर
Hello?
सर योभन्दा अगाडिको क्लासको अपलोड गरिदिनु न पिडिएफहरू
Okay.